Hello, this is Alex Yazdani. This is my video demo for Lab 1 of EE533 with Young Cho. The date is January 18th, 2025. I'll start here with just the code that was provided to us for the server and client with no modifications yet. I have two VMs open. It's Ubuntu and VMware. The left is a server and the right is a client. So if I run the server with port 8080, just a convention. Then I do a client, just send hello world. We see that it's received on the server end, and the server sends a message back to the client to let it know that it was received. And this IP address that I'm using here, I got using, let me get that command. Saved it down here somewhere. Just this. So on the server side, I can paste this, and that tells us the IP address. So that's what I used on the client. So after we ran this, there were a few enhancements and extra features we could add. For one, we want the server to be able to handle multiple clients at once. Right now you can see that there's one client connects, and then once they communicate, the server just shuts down. So we're able to actually add a for loop inside the server, or a while loop, excuse me, right here. And you just make sure this is saved. And there's some extra stuff in here that I'll get to later, but so let's recompile that. So this is the shared folder, server C, place that. Then I just need to recompile that. Let's clear that. And then we'll run this, so we can see the server is running now. Let's connect again. Hello. Goodbye. I can send multiple messages on here. I can also open a new terminal and can do the same thing. So there's one issue here. This is working, but every single time a client connects to the server, it creates a zombie process on the server side. And actually, if I open another terminal here, I think if I do ps-ox defunct. So all three of these are zombie processes, and there's one for each of the messages that I sent from a client. Now, if I close the server, we'll see that it's gone. And this last one here is just, it's this ps command itself. So now that there's nothing going on, there will always be one. But so there's just one line of code here that we just add that in on the server side, save that, and then we can recompile, and we should see those zombie processes go away. So this is shared folder. So replace that. And let's clear that. So just started the server back up again. Let's send a few messages. So now we can see that the server is still running. So let's check if there's any zombie processes. So there's just the ps command itself. So there's no zombie processes running with that one fix. So I think the next part of the lab, after handling multiple clients and then handling the zombie problem, was to implement datagram sockets. And so I tried to do this in a bit of a clever way. I right now by default we're using TCP, so we're using streaming sockets, but there's a few changes you can make to use UDP protocol at the transport layer, so datagram sockets. And I used here a preprocessor directive to easily switch between UDP and TCP. So if we just uncomment these two lines in both the client and the server, it enables UDP, and this actually changes which part of the code gets compiled. Now that this is enabled, this part here won't compile, but this part will. The only real changes here are that we're using receive from and send to instead of read and write, and there are some other changes that need to be made as well. Like for here we're using sock datagram instead of sock stream. You also don't listen or accept with UDP, and there's some changes on the client side as well. Very similar stuff. So let's go back into here and I'll recompile on each one. So server, and I'll just minimize that. So here's the shared one. So just recompiling right there. Let's get rid of these extra terminals for now. I don't think I need them. And let me just double check. So yes, I did save everything. So let's try this out. Hello. Goodbye. So this is still working effectively on our end. It doesn't look like anything's changed, but we are using UDP instead of TCP. So in practice, that means that packets can get dropped. The trade-off there is that with UDP, you get a higher throughput, lower latency. The improvements are there, but it doesn't come with the reliability of TCP. When you use TCP, you're guaranteeing that the packet will get there. In UDP, it can be dropped. So that may be better for certain applications. And the final thing we did here was that we can use sockets in the Unix domain instead of the internet domain. So let's open another terminal here. So we were provided two other pieces of code to do this. So I think all I have to do, I should have it compiled already, is you do something like this. Instead of a port number, we're just going to put a file location. So let's just do socket. That one's already in use. So maybe we do socket 2. Socket 3. So on this side. So there, using the Unix domain, we have successfully sent a message from the client to the server and back. So that's all. Thank you very much.